This is Mr. Barron. I'm going to be showing you how to do a percent yield problem. The problem that I'm going to be using as my example is problem number 77 from chapter 3 in the AP Chemistry textbook. In this problem, you're given a hydrocarbon C6H6, which is called benzene, which is reacting with bromine, Br2, and you're producing this compound and this compound. Okay. The given information is that you started with 30 grams of this and you started with 65 grams of this guy. What they're asking for is what the theoretical yield is. This is a limiting reactant problem before we even get into the percent yield part. The percent yield part will come in later because it turns out that the actual yield for this compound right here, which will give us a ballpark when we're calculating our theoretical yield, which should always be higher than the actual yield, and the actual yield ends up being about 157 grams. Oh wait, no. Getting it. It's 56.7 grams. That's the actual yield. We're trying to calculate the theoretical yield and then figure out the percent yield. Okay, it's a limiting reactant problem because you don't know which of these you're going to run out first. Whichever one runs out first is going to end up producing the amount of the compound that we're going to calculate the theoretical yield for. So in doing this problem, I want everything in moles. So I'm going to divide by the molar mass of benzene, 78.11 grams per mole. This one, divide by the molar mass of bromine, which is 159.8 grams per mole. I end up with 0.384 moles of benzene, which is C6H6. And then I also end up with 0.407 moles of bromine. Now, this chemical equation is already balanced, so everything is in a 1-to-1 ratio. So however many moles of this I have is how much theoretically I'm going to produce of moles of this, and same for this to this. Notice that this is my smaller amount. Because it's the smaller amount, it's of course my limiting reactant. Because it's my limiting reactant, I know that since it's a 1-to-1 ratio, and I'll actually bother writing it down, 0.384 moles of C6H6. Multiply it by the multimole ratio, which is 1 to 1 between C6H6 going to C6H5Br. Of course, it's moles to moles because it's a multimole ratio. And naturally, I get exactly the same amount of product as I have of my reactant in a 1-to-1 limiting reactant situation. So I have moles of C6H5Br. Okay, so I'm going to have to take this number, and then I'm going to multiply it by the molar mass to figure out how many grams. Turns out the molar mass I'm going to multiply it by is 157 grams per mole, and that's for the C6H5Br, which I've added up ahead of time. And when I multiply those two numbers, I get 60.288 grams of my product that I'm analyzing, which is the C6H5Br. Okay, so this right here is my theoretical yield. To figure out my percent yield, the formula for percent yield, which you must memorize, is always actual over theoretical times 100, every single time. You're always going to end up with a percentage that's going to be, in the AP test, probably between 70 and 100. So I'm going to take 56.7 grams, keep the same number of sig figs, dividing it by 60.3 grams times 100, and that'll give me a percent yield of about 94%. That's the answer to this question. If you have any other questions, please let me know.